All right. All right. I see people trickling in, so I am going to get us started. And as folks continue to join, we will be sharing some information, some housekeeping items. But yeah, so first off, this webinar is in collaboration with Kibo. The topic is Snowflake performance tuning, what data teams get right and often what they get wrong. We're going to talk about the core principles of performance tuning, how we identify and avoid some of those frequent errors, and how we implement practices to achieve optimal performance using Snowflake. We have two wonderful presenters with us today, Isabella and Anna. Both are co-founders at Women on Snowflake. All right. So our agenda today, like I said, we're going to cover some housekeeping items, introduce Women in Analytics, introduce our sponsor, Kibo. Then we will let our presenters get into their talk for the day. And at the end, we will cover some questions and close out. So if you have any questions throughout, please drop them in the Q&A box and we will get to them at the end. So this series is part of a 3-webinar series on mastering Snowflake optimization, performance tuning, and cost management. Like I said, this is going to be a 3-part series. So we are going to be covering some of the valuable insights and strategies for enhancing performance and cost efficiency while utilizing Snowflake. So if you are interested in joining us for the rest of this series, we are going to be here every other Wednesday. Our next webinar on 9/18 is going to be on unlocking advanced Snowflake optimization, data insights for peak performance. A little bit about Women in Analytics. So our mission is to increase visibility to women and gender minorities in the analytics space, as well as providing a platform for those individuals to lead these conversations on some of the really amazing work and topics that they are working on. So if you would like to get involved in the community, you can sign up for our newsletter, keep up with our events calendar, and also join us on our community platform to take advantage of some of our courses, all of the video recordings we have from our conferences, and participate in things like our mentorship programs. Oh, I see we have a Q&A, just checking in on that. If you're interested in getting connected with WA, you can scan that QR code. It will take you to our website, or you can go to womenanalytics.com and check everything out. A few housekeeping items for the webinar. If you have any questions, again, drop them in the Q&A box and our presenters will get to them. If you are having any issues with the webinar, send us an email and we will get you sorted out. And if you want to keep up with us for future sessions, future events, you can sign up for our newsletter, follow us on social, or again, join the community platform and get all of those cool updates in one place.
To save on Snowflake, you could stare at queries trying to make them faster, or tweak warehouse parameters by trial and error, or you could use Kibo, the only fully automated Snowflake optimizer. Our patented AI constantly evaluates dozens of parameters to make the right adjustments at the right time. We set up in minutes, and you'll start saving in just a couple days. Contact us for a demo, and we'll show you how.
All right, fun video from our sponsor for this series, Kibo. So a little bit more about Kibo. Kibo is the world's first fully automated Snowflake cost optimization solution that offloads manual optimization efforts data teams get bogged down with so that they can focus on innovation and growth. Based on years of cutting-edge research at top universities, Kibo's patented technology uses AI and machine learning to maximize your cost savings 24/7, while keeping you in control with sliders to set the balance between cost savings and query performance, and rule settings to adjust for complex scenarios and schedules. Kibo learns and adjusts to workload changes in real time, automatically optimizing warehouse size, clustering, memory, to find savings without sacrificing performance. So Kibo goes beyond the typical observe and report solution, although they do have that available as well, to actually automate your optimizations so you never miss an opportunity to save. The platform uses only metadata, never user data, and provides full verifiable visibility into your optimizations and savings. And even more exciting, no changes are needed to your warehouse or applications, and Kibo only charges a portion of what they save you, so there's guaranteed ROI. And setup takes just 30 minutes, and you'll see savings in just 24 hours. So if you want to see why customers like Costco, Allbirds, Caring.com, Freshworks, Barstool Sports, Komodo Health, and many more trust Kibo to help them save time and money on Snowflake, you can get a personalized demo and start out with a free 2-week trial to see how much Kibo can save you. And to do that, you can head over to kibo.ai. All right, so now to get into our topic for the day, I am going to turn it over to our two presenters, Anna and Isabella. All right, so take it away.
Hello, everyone. So first of all, thank you, Lauren, for the nice presentation. And of course, I would like to say good morning, afternoon, or evening, everyone, depending on where you are joining us today from. So I'm really excited to be here today with Anastasiia, representing women on Snowflake. And yeah, for those of you who don't know us yet, let me just give you a very brief overview. So Anastasiia and myself, we are friends and former colleagues. And during one of our long chats, we were just reflecting on something important for both of us. And we realized that women are often underrepresented in the tech world. And we wanted to do something to change about it. So that's why we started Women on Snowflake. It's a voluntary activity that we are doing. It's a user group. And we created this at the beginning of this year. Our goal is just to support and empower women who are eager to learn Snowflake, because we understand that finding the right resources can be challenging, especially if you don't come from a very technical background. And so far, we have hosted 5 user group meetings. We welcome over than 130 members in our community. And we manage also to grow our LinkedIn page. And we are also active on meetups. So we are very happy to connect with all of you. Just a few words about myself. My name is Isabella Renzetti. I'm a data analytics consultant and trainer. I have 10 years of experience in data analytics, and right now I'm working as a freelancer. And since last year, I've been also part of the Snowflake Data Superhero program. And I'm very passionate about coaching and mentoring women in tech. So now it's also time to pass it over to Anastasiia.
Thank you, Isabella, and thank you everybody who joined us today. Isabella, you did a great job. I will not repeat myself about Women on Snowflake and how passionate I am about the topic. So really briefly about myself. I'm a data analyst by day. I work in travel company TUI, which comes from Germany, where I'm geographically based. So good evening to people joining from Europe. If there is anyone, I'm happy to see you there with us today. And as Isabella spoke already about where you can find us, Women on Snowflake is available on many platforms. You can just Google for Women on Snowflake and we will be there. The QR code is to our official user group page where you can sign up to follow all our future events. And I'm delighted to mention that our next user group meeting is taking place offline in London on the 10th of October during the Snowflake World Tour. So if you are based in the UK, or if you're able to get to London on the 10th of October to join us for breakfast, when we're going to talk about the data disparity and how to close the gender gap in data, we would love to connect with you. But no worry not, usually our user group is virtual. We host roughly monthly virtual calls. So the QR code and the link are there for you if you would like to be part of what we are doing and connect with us closer. Of course, feel free to connect on LinkedIn and other platforms as well. All right, with that, let's jump to the topic and what are we going to discuss today? Isabella, back to you.
Yes, so our agenda for today, it will be very simple. We will start talking about the life cycle of a Snowflake query, analyze a little bit of also micro-partitioning, pruning, and clustering as well. We will have a look at some query compiling tips, and as well as query execution tips. Then we will wrap the topic, and as mentioned before, we will have some Q&A at the very end. Okay, so I think we can jump into the first topic, and we will dive deep into the life cycle of a Snowflake query. So in a nutshell, the query lifecycle in Snowflake starts with an SQL statement and follow several steps. So at first, the query is received. So the SQL statement arrived usually via ODBC, JDBC, or the web UI. So you can see like the point 1 also in the image on the right. Then the result cached is checked, because we know that Snowflake will check first if this result is already there in order not to consume any additional cost. And if it's there, it will return the result immediately if we found them. Third step is the planner and the optimizers. So Snowflake will analyze and optimize the query, and it will identify the necessary data. First step, we are going to talk about the virtual warehouse processing, and over here the data is scanned from the SD cache or the storage. And at this point, Snowflake identifies exactly data that is needed, and then it will send to the cloud services. Final step, so step number 5, the final results are processed. They are stored in cache for future use, and they are returned to the client. So pretty simple. On first sight, but of course, like we know that we have to specifically pay attention to each step in order to make sure that we are able to optimize the query as much as possible. Okay, so understanding, of course, the life cycle is I would say it's a key to optimize and also troubleshoot the query performance in Snowflake. So if we can also move to the following one, thanks. Yeah, so, and why we are talking about the micro-partition now. So micro-partitions are that elements in Snowflake that are at the very heart on how Snowflake organizes and optimizes data storage. What are they? So usually micro-partitions are essentially small immutable files that are about 16 megabyte size, and this size is optimal for balancing performance, but also storage efficiency. Also, micro-partition use a storage format that, let's say, blends columnar but also row-based storage. What it means in practice is that the data within each column is grouped together and compressed. And Anna will also dive deeper into micro-partitioning in a moment. And also, when we talk about micro-partitioning, it's always important to keep in mind that micro-partitioning are used to optimize the performance. So again, columns grouped to speed up query processing. And you can also have a look at the image on the right to better understand what micro-partitionings are. Okay. And also what is also important to keep in mind is the query profile, because we know that in Snowflake, the query profile is that tool that will allow us to effectively understand how Snowflake processes queries. And also, I would say it's a very nice visual representation to understand the different steps how a query is processed. So at first, we can find the filter, the actions. So Snowflake apply query conditions, for example, where clauses to narrow down the data sets. Then the join operation comes, and the join, of course, we know that it merges data from multiple tables based on specific join condition. And also, this part is very important because we want to avoid, for example, join explosions. And also on this topic, we will come back, and especially Anna will talk more about the join. Then we have the aggregate function. The aggregate, what it does, essentially, it summarizes data using functions like sum, the average, or the count. Then we have the window function that they perform calculation across related, for example, rows for more complex analysis and calculation. And then the very last one will be the sort, because we know that the sort is also taking some effort, some computation efforts, and the data is organized according to specific criteria, such as the order by. At the very end, Snowflake will write the results, so the formats and are just like presented in the final query output. So throughout all these steps, Snowflake is able to optimize each step using statistic to ensure the performance. And in what I forgot to mention is also in the query profile, we are able to see the statistics on the right. Okay. So now that we have covered the query profile, how about we explore the partition, the pruning, and also clustering? So I will pass the presentation to Anna.
Thank you, Isabella, and I happy to accept the presentation from you. So Isabella just showed you the partitioning. I bring this picture back. Partitioning, just for us to remember what things are, is physical files which a logical table is divided into. Well, sounds pretty easy. Let's think of it as pages in the book. Pages contains books, and each book has a part. Each page has a part of the book. And let's simplify this example. Let's make it an address book. So here on the left, you can see a name, very simple. Names in our address books are just letters, and the addresses are just country codes. You also have the type of the, perhaps it's the customer, and you have the date at which the address was added. So this is an address book of a salesperson, and the salesperson is so the address book is divided into pages. Some of the addresses are on the first page and some on the last. These are the partitions. So far, so good. So now our salesman wants to find out what was the address of the person they just added yesterday on the 5th of November, and that's the right box out there in the bottom. For the salesman to find it, they just go to the address book. And since the addresses are added chronologically by date, it's easy. They just go to the last page, and voila, the last page contains the addresses for the 5th of November. Amazing. And what we've just did, we've done pruning, because we were smart to know that the last addresses were added on the last page. So we skipped looking all the previous pages, all the previous partitions. We don't need them, right? We just look at the last page because that was the last date, addresses added on the last date. And that is what Snowflake does automatically for us, and that is called pruning. So we have a logical table. It's partitioned in some way, natural way of partitioning by the way the data is added. And then when we need data for a certain time or for other certain parameter, the Snowflake will only read the partitions from which contain the actual data. And that is achievable by Snowflake always maintaining accurate and up-to-date metadata about partitions. So that book of ours, address book, it has bookmarks, and Snowflake knows for which date we have the for which date we have addresses on each page, which micropartition contains which data. Well, you will stop me here hopefully now and say, wait, Anna, you cheated a bit, because address books don't work by dates, don't they? They usually work by names. This is the address book, and usually the salesperson would like to find the name or the address of a person by name. What happens here? By default, we don't have this table or micropartition sorted by names, which is quite unfortunate, because if we, for example, want to look at the addresses of people with the name A, we would exactly have to scan all these micropartitions highlighted in red, because each of them has a name which contains A. So no optimization here, quite unfortunate, but wait, we have you covered. For that, Snowflake has created, and we as the business users of the data can suggest ways of clustering data. Clustering is effectively sorting. Clustering is a way for us to tell Snowflake by what shall we organize these micropartitions. So instead of a situation like here on the top corner, when we have to scan through all the address book to find all the addresses, if we divide the table into micropartitions by the key, by the clustering key, which makes sense to us, in this case, name, then what we come to, in the end, we will only need to read the micropartition which contains the name, and that will significantly simplify our performance. Automatic clustering is present in Snowflake and available for everybody. We are very much recommending it, and I think at least 3 more times in this presentation alone I will mention automatic clustering, because that's really a powerful feature which can be used for good, especially if you have these limitations in mind. First of all, the sorting data by a particular key is an expensive operation, so you only want to do it for cases when it matters. So don't sort by everything at the same time. Choose those clustering keys, which really matters. In example of address book, that would be name. But for your business, of course, you know it better. Well, you say you know it better. Those keys will likely be used in where condition or in joins. So think of columns that are frequently joined by, or columns which are frequently filtered by in where conditions. Those would be the good candidates for clustering keys. Don't use more than 3 or 4. That's an official recommendation. Otherwise, it becomes less efficient because there is too much sorting to maintain. You want something which has quite a few distinct values, but not too many. So one example would be if we have an address book which contains a country code, but the salesman only operates in one country, clustering by that country would achieve no result because you're sorting by one value. On the other hand, if instead of date of adding the address, you would have a timestamp, which is like a milliseconds, which is a very granular value. You will have way too many and it will always have to resort it. So it's an expensive operation and should be avoided. If you have a situation like a timestamp and you want to ensure it's part of clustering, create a separate column, which is, for example, a date. Okay, so with that, if you want to know more about clustering, we hope we'll be able to give you links after the webinar included in the description where you can read more. And a pro tip, in addition to clustering, we're not going to cover it today. It's called SOS, Search Optimization Service. It's a service complementary to automatic clustering, which allows you to optimize even further those highly selective queries where you, for example, want to search for a part of a string, or if you want to use data which is semi-structured, such as variants and objects. Look it up on your own. We are unfortunately limited on time, but just keep in mind automatic clustering and search optimization, they're complementary, they work really nice together. And with that, I believe we covered the optimization which you can achieve by structuring your data in the best way. Well, which brings us to the next point. After we've reached the data, what was there in the execution plan? Right, we need to compile the query. I'll pass back to Isabella for that.
Yeah, thanks, Anna. So now that we have talked about clustering, let's now focus on the query compiling tips. So we can see how this can really help you fine-tune the performance. So what we are going to look now, we have a look at the compilation time and why it's important, because we know that a long compilation time can slow down the query processing. And we also have a look at a long execution time. So this happens when the queries, they just take too long to run. And inside this topic, we'll also have a look at the long stable scans. So extensive scans, can be a sign, of course, that a query could benefit from some optimization. We will have a look at the out-of-memory errors and spillage. So these issues can also indicate that the query is a bit, let's say, too resource intensive. And finally, we will have a look at the inefficient execution plans, because we know that plans that are, let's say, poorly designed can lead to suboptimal query performance. Okay, so let's focus on the very first topic. So it will be it is the long compilation time. So what is it again? It's basically how long it takes Snowflake to prepare a query for execution. So if a query takes a while to compile, then the overall process can be delayed and can impact performance. What are the causes, you may ask? There are different. Of course, large data, because more data means longer compilation. Small files also, because small files or frequent small files inserts can slow things down. And of course, complexity. What do we mean by complexity? For example, a lot of columns, nested views, complex expressions. All these things can increase the compilation time. What are the solutions? Also depends, but some of the best practices can be identified in the auto-clustering. So we just saw that clustering combines small files into larger ones and helps also data pruning. Another solution can be like to limit the columns. So try to limit the number of columns under an X number, let's say. And of course, simplify the views and the roles. So in order to reduce nested views and row levels, if this is possible. On the right, you see an example of the queries that can help identify queries with a long compilation. Also, we are careful about time, so let's just move to the following one, query execution. And it's all about preparing your query. So we have to make sure that, we have to understand how long also the query takes to be executed. And again here, why a query takes long to execute. Different factors, different causes. Could be like a long table scan. So full table scans can be slow, especially with large tables. Out of memory errors and spillage. So high resources usage might lead to data spills or OOM, so out of memory errors. And again, they will slow the query execution. And then third point is around the execution plan issues. And then these comprehend different things, let's say. So we can find the join explosions. Anna will talk about this, the join order, the cardinality estimations. So what are they essentially? Join explosions. It happens when a query produces too many, let's say, intermediate results due to a join that is probably not very well structured. A join order, an inefficient join sequence can also affect performance. So the orders in which tables are joined is critical. And finally, cardinality estimation. Incorrect estimates of row counts can lead to queries that are not optimal. Okay, so moving to the next slides, I will just try to be very quick. Long tables scans. What do we do in case we have bottlenecks? So we have to pay attention at number of files, because again, more files equals to slower scans. We have to pay attention at the filters that are applied. So effective filters can reduce data scans. Filter selectivity. So it's important to use precise filters in order to improve performance. Clustering. We understood that well-clustered data can speed up scans. And finally, filter push down. So filter push to storage, optimize the performance. Okay. Again, there are also, let's say, different ways through which we can have a look at the queries with poor pruning. In here, I just put two of the main queries that usually are utilized to identify, either with the operator analysis or the query level monitoring. I think we can also speed up on this process to leave enough time to cover also the out of memory errors and the spillage. So perfect. Over to you.
Thank you, Isabella. And well, I hope we have still a good moment of time to zoom into the remaining topics and the remaining problems, symptoms, and how to make sure that we cure them as much as we can in Snowflake. Isabella already mentioned out-of-memory errors and spillage happens. On the right-hand side in the query profile statistics, you will see this picture, spilling bytes spilled to storage, and then, well, it's going to be large. What happens in the backend when there isn't enough memory for a query to hold the results or intermediate results all in memory? It's going to spill to disk. It's going to write the intermediate results and then read from it to make sure that it is understanding, that it's catching up and taking it all. What is bad about it? Well, I/O is always slow. I/O is slower than processing data in memory. So when we're talking about the out-of-memory and spillage errors, they are slow because writing to disk is just slower than keeping things in your memory. And why can this happen? Very simple. There are two main causes which can trigger out-of-memory errors or spillage. First is the intermediate result of one query is too large. Why is that? Because it scanned too much data, because it produced a join explosion. Well, it's a too large intermediate results. We want to avoid it and we have to filter the data. Automatic clustering can help. More selective filters can help, making sure that the data which gets into memory is only what we need to process, no select stars, what can help as well. But second option is that there are just way too many queries at the same time on your Snowflake cluster. So each of them individually is small, but they are spilling to disk because altogether they are just taking all the memory which is available. And that, of course, automatic resizing of the cluster can help, scaling up or scaling out can help. So consider some optimizations on the level of your warehouse there. And of course, when we talk about the spillage, the main outcome of the exercise needs to fit the data in memory, so reduce the data. So the tips that we're going to use for the next symptoms will also help us with spillage. Just keep in mind, most of the things that we're discussing today are about reducing the volume of data we process to get it processed faster. Okay, with that, here are the queries. We will leave them as reference. Video will be available. Feel free to reference how to identify queries with spillage. And I move on here to my favorite, least favorite situation, most favorite topic, which has to do with joins. Because the moment you learn them as a data analyst, you just start joining everything. It's just suddenly the world is magic. It's like VLOOKUP on steroids, and you can do whatever you like. And that comes at a cost. So today we're going to discuss two join issues which can occur, how to prevent them, and how to cure them. And the first is called join explosion. Join explosion, something that Isabella already mentioned, and you can also identify it in query profile. So on the right-hand side, you can see that we're joining two tables. Each of them has quite small amount of rows, only 10K on the left and 5 million on the right. But then when the tables are joining, what happens here, we have almost 9 billion rows. And that usually, under normal circumstances, not something that as an analyst you expect to happen when you make a join. Why can this happen? Well, first things first, maybe there is a duplicates in the data. This can totally happen and happens to the best of us. So making sure that your data is not duplicated is really important. Second, well, perhaps there is a non-unique key and the join condition is really not optimal. It's just joining too many rows together and that causes the explosion. The most ultimate edge case of such is no join key at all. So we're creating a Cartesian product, multiplying all the rows by all the columns, and then it just becomes huge. Why is it bad? Well, again, it can cause spillage. It's going to be a long table scan. It's going to take forever. It's going to take longer than we want. So we try to limit and remove the join explosion. How can we do it? More filters, pushing filters down into the execution plan, more keys on which we join, never leave it as a Cartesian product. Joining the small tables first, I'll touch on this in a second, that's the very important one, but make sure that on the left side of your join is always the smaller table. That will be really helpful, and Snowflake will include a lot of automation and optimization on that. And if you cannot avoid the join explosion, because that's the logic in your data, then the suggestion which I will have is to make it a temporary table. And in that way, it will be possible to join it and save and then continue working with this data from disk. It can also lead to some additional optimization. And with that, we're coming to the last topic about joins, and that is the join order. For that, I brought you this brilliant illustration, which I hope by now you recognize as a query profile. So on the left-hand side, we have a query profile which is leaning a bit to the left. On the mirror of it is the central query profile, which is leaning to the right. They are called left and right deep joins, respectively. And on the left-hand side is a combination of the first and second one, which is called the bushy join. We will leave it out. It's a combination of the two. And whenever you look on your query profile, you will see one of these pictures, right? Your join tree will look one shape or another. And a tip from us, and something we'd like to close the day with, the last tip, which is very important, is number 2, the right deep join is the join shape that you always want to achieve. That is the shape of your query that will be the optimal. The reason for that is very simple. Snowflake on the backend identifies the profile of the query. If it notices the left deep join, it will apply the nested loop join algorithm. That's naive algorithm. That's joining everything row by row by row by row. It's going to be relatively slow. If it identifies the right deep join, however, it will make it a hash join. Hash join is a two-stage join. You have a build phase and a probe phase. In the build phase, the smaller table, which should always be on the left, is hashed for the values which are going to be joined on. And then on the probe phase, the large table is probed for the values from the build phase, which makes it extremely fast, much faster. And it's possible to benefit from the parallelization. You can benefit from the clustering, so you can benefit from the scaling opportunities. And you should always try to achieve that performance. Well, we know that Snowflake makes it automatic for us. So if you want to control the order of the joins, you can also create it using temporary tables and maybe defining the views. That's the last tip we had for today. I know we are at time and we really wanted to bring the most of our knowledge for you today. So at this moment, we're opening the stage for Q&A, and I think I'll need to stop sharing my screen to see Q&A as well. Lauren, please help us with that. We are saying goodbye to the slides, and we would like to stay in touch. So yeah, stay in touch wherever you like, and thank you very much for having us.
Thank you.
All right.
All right, if you have any questions, please drop them in the Q&A. I think we have time for 1, maybe 2 questions.
Okay. Let's see if we have any. Well, we see a question popping up about the certificates. So the certification program is available on Snowflake. We are the community, so we do not distribute the certificates, but you can get certified for Snowflake. And I believe we have a few certified people on the call. Isabella, I know you were in the past certified. I am still to get there myself, but Snowflake offers very extensible certification if you're interested in that. Okay. Oh, Lauren, thank you so much. You answered a couple of questions on the go. Yes, the presentation and recording will be shared.
Oh, we have a bunch popping in. Yes, we can share, I think we can share slides afterwards, a link to those. All right, let's pick one more question to wrap this out. So I'll turn it over to you. And any other questions, I'm sure we can have folks reach out and continue these conversations offline. But yeah, let's end on one more.
I already jumped to type in the answer, so I'll try to be super brief. Can we create index manually to boost performance? Clustering can be redone manually. You can follow automatic clustering, or you can set up manual reclustering. And please pay attention to the cost, because every time the data is updated in the table, the automatic clustering will happen again. So if the table is updated very frequently, perhaps automatic clustering is not the best idea for it.
All right. I think we can do one more. We're okay on time, and then we can wrap things up.
Yeah. So a lot of question about sharing. Yes, it will be shared. Can men join the user group? Of course, like we are very happy to, of course. I mean, we are an inclusive user group. Let's see if we find something more about users.
We have one about using window functions for query optimization. I think that could be a good note to end on.
Yeah, so Windows function, as we saw in the query profile, are one of the, let's say computational that can be performed in Snowflake. As this is a steps that might, let's say, cause some suboptimal performances. We mentioned window function because it's something that we have to, of course, can be used in a query. It's just like it's something that users have to probably focus at the attention a little bit more, because we don't want to make Snowflake taking more time and more, let's say, computational cost. Window function are all these, just to reply better to the answer to the question, sorry, is they are those features that allows to perform let's say, I would say, more advanced calculations, because they are performed on a different level of rows. Yeah, and yeah, that was probably
awesome.
yeah.
All right. Well, to wrap this up, thank you both so much for joining us and for your presentation today. Again, this was just one of these sessions in this 3-part webinar series. So we hope to see you again in a couple of weeks. Recording will be shared soon. Resources will be shared as well. If you have any more questions, we are going to download those. We encourage you to connect with our speakers. They're incredible. We've just seen that they both have a lot of expertise. So yeah, as we wrap this up, thank you both again for joining us. And I hope everyone has a great Wednesday. Thanks so much.
Thank you for having us.
Thank you for having us. Thank you.